Okay, so I've been really busy working nights and just trying to get these flashlights perfected. And this was the first one that you saw in my previous video. And I went ahead and completely encased it, so it's now a finished prototype. It's nice and strong. I then moved on to this model, which I am now naming the Tesla Torch. I got the domain name teslatorch.com. And I've got some plans to proceed with this. I know a lot of the subscribers on YouTube were telling me to do a Kickstarter. I've researched that, I've thought a lot about that, and someday I may do that, but I'm going to go ahead and give you my plan on how I plan on proceeding at this point. But this little unit I really like. You saw that one, you shake that one for 3 seconds. The neat thing about this unit is that it charges faster than I could achieve through shaking to a higher capacity. So let me just show you what I mean. So I'm going to give this one 3 seconds of charging. 1,000, 2,000, 3,000. All right. Now this, it's really bright in comparison to what I was able to get out of the other design. And at 3,000 or so seconds, about 3 seconds in, if you notice, the spot really doesn't get brighter and it spins very easily. And that basically means you've achieved full charge. So that's full charge in this one. 3 seconds of shaking pretty much charges this one as well. So, you know, we got, but you can see the difference in light intensity, and I'll turn out the light and do a better comparison to that. So let me flip the lights out and I'll show you what I mean. Okay, so we got the lights out and I'm just going to show a comparison. So here's the original SJR Looper flashlight, and here's the Tesla Torch, the latest version that I'm working on. So this is the first Tesla Torch prototype. So this was the first Tesla Torch case, and I've got the new case designs printing out right now. So I got both 3D printers printing. The new case is going to be smaller, a little more compact, should fit in the hand a little better, and hopefully it turns out good. Okay, so the new case printed, and I have made a few changes over this model, so kind of interesting. So it's more compact, for one thing. Let me just snap the two halves together here. So yeah, it's more compact. It fits in the hand very nicely. So here's a size comparison between the two. So I was able to get it down, fit tighter. I really like the design here where the handle tucks away into the case. There's kind of a little more room for the handle to fit, and it fits nice. It's inset, it's protected, and yet it's very easy to get in and out. So in this one, you know, it was a little bit more of a specific fit. You really have to line it up perfectly. But anyway, minor improvements. You can see that this one is a little bit thinner and definitely more compact when you look at it this way. So yeah, the design keeps improving. I've got to go ahead and get the driver and the LEDs put in this one, but this one will be ready next. Alright, so as I was saying, I've been developing these. I've thought about the Kickstarter program. I've thought about all of the different things I can do, and what I've decided I have the time to do right now. You know, I'm spread pretty thin on time. But what I do have the time to do at this point will be to sell the prototype units. So I'm going to be putting this one up for sale, and I'll put them up for sale for basically parts costs. So you will not get a better deal on a 3D printed probably anything if you go and check at Shapeways or something than the initial starting bid price on these. I've created a new website. It's called teslamaker.com. I've also created a YouTube channel for it. And the reason I'm splitting my YouTube channel at this point is I don't want to fill my main Laser Saber YouTube channel and Laser Hacker website channel with multiple flashlight prototypes. You know, I've got a lot of other projects going on, and I want to continue for that channel and that website to showcase the variety of my experimentation, not just be this one dedicated thing. So I've got teslamakers.com. Check out this video description for links to this, and you can check this out, and Tesla Maker YouTube channel. So if you subscribe to that channel, you'll be updated every time I put up a new prototype for sale. And anything they go above the starting bid is basically going to go above the cost of materials and go directly into funding more research, more prototypes. So it's kind of a self-funding, you know, crowdfunding type idea, but the difference is there's no risk. It's not like on Kickstarter where you're throwing in a lot of money and then I have to go off and build 100 or 1,000 of these and send them to all the people that gave a donation. In this case, when you place a bid, if you're the high bidder, you get that particular prototype. And you know, I'll continue to build more prototypes. And Tesla Maker will not just be a place for prototypes for these. I'm going to call this the Tesla Torch. I got teslatorch.com, and I'll probably point to that website as well. But, you know, Tesla Torch is one of many prototypes I want to do. I want to do the Solon-1s. You know, I want to do a lot of different things going into the future. So I've decided rather than, you know, populate my main YouTube channel, my main website with those prototypes, I'll just separate it at this point. Those who are interested in maybe buying a prototype instead of building their own, they'll definitely want to subscribe to that channel and follow that website. So check that out. Let's move on now into the overview on this video on the coils and how I'm winding this coil and some of the updates along that line. So. Okay, so on this part of the video, I want to show how to wind the SJR Looper Coil. And this is the coil and ferrite that I'm using in the Tesla Torch flashlights that I'm making. I've done a lot of testing with my lux meter. This coil works excellent at these dimensions, at these ratios. Now this wire, it measures 0.55 millimeters. I think that's about a 24 gauge wire approximately, but 0.55 millimeters on the diameter of this wire. So I just take one of these little clips, and I've got a bolt here that fits right around the bobbin snugly. And I take one of these clips and I just clip this wire down to get the winding started. So anyway, that's the first part. And then let's see if my drill's set on the right direction. So it's rotating this way. And I just go around here and go with one layer to the bottom. And then back to the top. And that's my primary. So the primary winding is finished, and it just will come off here on the side like that. So I'm just going to go ahead and clamp that side of the primary down, and then we'll clip the wire and do the secondary. Okay, so time to put on the secondary, and the directions stay the same. And what I'm calling the secondary here is what connects over the LEDs. You'll notice on the previous schematic I had more turns on my primary and fewer on the secondary connected to the LEDs. That worked great for a certain type of experimenting I was doing, but I get greater light intensity with this particular setup for the Tesla Torch lights. So here we come now with the secondary. So we're going to start here, and for this one we just fill it up to the edge of the bobbin here. So we'll start here. Now that I've gone one layer over, I can take this one off. And actually, we can take this one off. So I'll make it a little easier to see what we're doing. Okay, so this is the final layer. And there we go. There's a nice little indented edge here on the bobbin to take that off on. Now usually I put a little dab of hot glue at this point. I don't have my hot glue gun running, but I've got some of this Scotch tape here and that will work. So this is just to kind of hold it together here on that last layer. So there we go. And that right there is the finished winding on this particular SJR Looper Coil. So anyway, I will scrape the enamel off these ends and solder these ends and put this in the ferrite core. Okay, so we've got the coil that we wound earlier, and I've got it connected here on my test bench configuration. So what I've got here is I've got the lux meter set up. I've got this 3D printed cup, and this cup basically has aluminum tape inside here, so it captures all the light and focuses it right down here. This lets me get a lumens or a lux reading here versus how many milliamps or microamps the circuit's pulling. I've got it set at 10 volts. This is a 10 volt 3300 microfarad electrolyte capacitor. I've got the scope connected across the leads on the capacitor, so I'm measuring across the DC voltage on the cap. And what you can see here, I hope you can see this on the camera, it drops down the DC voltage and it kicks back and rings very nicely, and you actually have a secondary ring here. Sometimes I can catch the second ring across the leads on the caps. You can see that there. That's what the voltage looks like across the capacitor. If you tweak the resistance here in this pot, you can see that change, and you can kind of tune this circuit. You can see right there we've got a very interesting ringing effect going on the DC voltage on the cap. So anyway, that's what goes on there. So I'm going to take this out, and it's going to run in a lower mode, lower current pole mode. But let me go ahead and just show you the waveform here on the coil. So I'm setting the probe on the ferrite, and I'm going to clip in here to the positive lead. And let me just bring this down where you can see it. Now you can see here on the curve that we have ringing on the slope of the curve down here in our waveform. So you can see a lot of ringing here, and that rings up. And if I was to put in a little more resistance, you would see that more. Actually, let me see if I can put in this resistor to, or let's just go back to the pot. I think the pot will show that very nicely. So there we go. You can see that ring across the angle of the waveform there. So let me go ahead and take that back out. You can see the ring coming up there in the scope. And let me go ahead and disconnect from the power supply here. So at this point, the circuit's running on this 10 volt 3300 microfarad electrolytic capacitor. So anyway, it's a great coil setup. So if you build this same coil that we wound here with these particular specs, get the same ferrite, same gauge wire and all of that, you should be able to get very similar performance to this. And you can see here, you know, we're disconnected, it's running away on its disconnected completely, and you can see that the waveform is very, very stable. And that's really what you're shooting for with a circuit like this. So anyway, that's really what's up on this particular circuit. So let me just drop in a little more resistance here and watch on the scope. Again, incredibly stable at that particular setting. So we'll up the resistance here a little bit. You can see that's a lot brighter. And there's the waveform now, and much, much brighter. Again, still no power added. This is still running off this 3300 microfarad 10 volt cap. So incredibly stable circuit, and just a lot of fun to experiment with. So I may go ahead and get some of the experimenter boards up at teslamaker.com so people can buy some prototype boards. At minimum, I would like to get some of the coils, wound ready coils for experimenting at teslamaker.com. So be sure to check that out. Anyway, now you've seen the video on winding the coil. Very simple, very fast, and also some of the test procedures. But again, check the schematic at laserhacker.com. I know a lot of folks complain about the wires, all the mess of wires. Look at the schematic. It's at laserhacker.com. Between the video and the schematic, you should have no trouble. So anyway, let's go on from there.